Welcome to our channel. In this video, we are going to discuss the concept of centripetal acceleration in detail. We will break down the definition, mathematical formulas, physical causes, and the difference between centripetal and centrifugal force. Following the sequence of this educational science infographic, let's begin with the first section. Definition and symbols. Centripetal acceleration is the acceleration experienced by an object moving in a circular path. Even if the object moves at a constant speed, its direction is continuously changing. Since velocity depends on both speed and direction, any change in direction means the object is accelerating. The word centripetal means center-seeking, which tells us that this acceleration always points toward the center of the circular path. In physics, centripetal acceleration is represented by the symbol a sub c, pronounced clearly as a c. Now, moving to the second section, key characteristics and visual diagram. Imagine a green car moving along a circular track. The diagram shows two important vectors. The first is the velocity vector, represented by v. This vector points tangent to the circle in the direction of motion. The second is the centripetal acceleration vector, a c, which points directly inward toward the center of the circle. The diagram also shows a 90-degree angle between these two vectors. This means centripetal acceleration is always perpendicular to velocity. Because of this perpendicular relationship, the acceleration changes only the direction of motion, not the speed of the object. Next is section 3. The mathematical formulas. There are two main formulas used to calculate centripetal acceleration. The first formula uses linear speed, as c equals v squared divided by r. Here, v represents linear speed, and r represents the radius of the circular path. An important concept to remember is that velocity is squared. This means if the speed doubles, the centripetal acceleration becomes 4 times greater. The second formula uses angular velocity, as c equals omega squared multiplied by r. Here, the Greek letter omega represents angular velocity. Now let's move to section 4. Centripetal force. The physical cause. This section connects centripetal acceleration with Newton's second law of motion. The formula is Fc equals m multiplied by c. This means centripetal force equals mass times centripetal acceleration. The infographic also provides real-world examples showing what supplies the centripetal force in different situations. For a car turning on a road, the centripetal force is provided by friction. For the moon orbiting Earth, the force is gravity. For a ball tied to a string and swung in a circle, the force is tension. And for an electron orbiting a nucleus, the force is electrostatic attraction. Finally, let's discuss section 5, centripetal versus centrifugal force. It is very important to distinguish between these two concepts. Centripetal force is a real physical force, directed inward toward the center of the circle. In the case of a turning car, friction provides this inward force that keeps the car moving in a circular path. Centrifugal force, however, is not a real force. It is an apparent outward sensation caused by inertia. Your body naturally wants to continue moving in a straight line while the car changes direction, which creates the feeling of being pushed outward. That concludes our detailed discussion on centripetal acceleration. Thank you for watching. If you enjoyed this video, don't forget to like, share, and subscribe to the channel for more science content made simple and easy to understand.